Welcome back. Tuesday, April the 7th, 2020. We're going to do a little math practice today. It's been a while since we worked with numbers. So here we go. Look at number 1 on the easel. It says 43 plus 16 equals. Now we're learning how to round numbers to the nearest 10. And we're going to estimate the sum. That means we do not say 43 plus 16 and write the answer down like we've done in the past. If you noticed in the directions you heard estimate the sum. That means you have to round each number to the nearest 10 and then you're ready to add to find the total answer. So 43 rounds down to 40. We can write that underneath. And 16 rounds up to 20. So if we were to estimate the sum, I think I need to bring you up close. 40 plus 20 equals 60. And so we would write 60. Okay, let's do the next one. 29 plus 11 equals. Round 29 up to 30. Round 11 down to 10. What is 30 plus 10? 40. Okay, let's work with mixed numbers. If the directions ask you to circle all the mixed numbers, remember a mixed number is a whole number with part of a number written beside it. So for example, 4 is a whole number. 1/2 is part of a number. Now put it together. 4 1/2. That is called a fraction. It's a mixed number because you have a whole number with part of a number beside it. So I'm going to circle 3 1/2, 13 2/3. Now why did we not circle 12 or 1/2 or 3/4? 12 is just a whole number. It was missing the fraction. 3/4 and 1/2 are missing a whole number. Okay, so to be a mixed number, you must have two things: the whole number and part of a number written in the form of a fraction beside it. Notice the whole number is written very large and the fraction takes up the same amount of space but written smaller right beside it. So let's practice. You write on your paper if you have scrap paper nearby. Practice this one. 7 6/8. 7 would be your whole number. 6 out of 8 would be your fraction. Okay. Now we're going to talk about time. Notice the time says 12:30. I want to write the new time if it was 4 hours from now. So I brought the Judy clock. I bet you've missed our Judy clock. I brought it home from the classroom. If it's 4:30 now, we're going to go up 4 hours. So I'm not going to have to move the minutes, just the hour hand. Because 4 plus 4 is 8. So my hour would be 8:30, okay? 4 hours later, for some reason I was thinking of 4:30 in my brain. We'll turn that 12 into a 4. 4:30 becomes 8:30, okay? So 5:30, if I wanted to say what would the new time be 4 hours from now. So on the Judy clock, I make 5:30. I know that 5 plus 4 is 9. So remember, my minutes don't change, just my hour. And my new time would be 9:30. And I would write it like this. Okay, 6 o'clock. Notice we have no minutes to worry about this time in our problem. So 6 plus 4 is 10. I'm going to move the hands to show 4 hours later. So it would be 10 o'clock. And I would write it like this. Now, if we want to do the next column, let's pretend on your paper it asks you to write the new time if it were 30 minutes ago in the past. 30 minutes ago, A-G-O. That means you're going backwards by 30 minutes, by a half hour. So we go back to the original problem of 4:30. So if you have a practice clock with hands, that's called an analog clock, set your clock to 4:30. Now just go backwards 30 minutes. So I'm going to go this way, 5, 10, 15, 20, 25, 30, and 30 minutes ago would be 4 o'clock. Okay, so look at how you would write that. Okay, 5:30, it would be the same way that we did the previous problem. Make 5:30 on your clock face. That's called 5:30. Now I want you to go back 30 minutes. 5, 10, 15, 20, 25, 30. What would be the new time? 5 o'clock. Just like we did that previous problem. Okay, set your clock to 6 o'clock. No minutes. Our little hands get tired, don't they? And they like to fall. Okay, 6 o'clock. Now you have to go back 30 minutes. So you go 5, 10, 15, 20, 25, 30. 30 minutes ago, it would have been 5:30, 5:30, because the hour hand is halfway between the 5 and the 6. 5:30, 5:30. So that was a little practice with rounding your sums and mixed numbers and time on the clock face. Next, we get to practice with money. Now this should be something that excites you, because I know you're probably doing chores at home during our remote learning and you're probably earning a lot of bucks, right? Remember on the board how we had our dollars? We would practice our $1 bill with George Washington and our $5 bill, Abraham Lincoln. And here's a play money for 10s and 20s. So those are called dollar bills, made out of paper. And then we learned all the coins this year. So we have some here as an example. The largest being the $50, 50 cents. Next, the $quarter, 25 cents. Next, the dime, 10 cents. Then we have our nickel, Thomas Jefferson's face, 5 cents. And last, we learned about the penny, Abraham Lincoln, 1 cent. Okay, so in this problem, we're going to think about what would I use to show this amount of money with the smallest amount of bills and coins. So if I were to make $7.56, I do not want to use 7 $1 bills. That is not answering the question correctly. The question said using the fewest amount of dollars and coins. If you said a $10 bill, you got tricked. I don't want to count back any change. I want exact change. So I have shown you on the easel that I would use 1 $5 bill and 2 $1 bills, because 5 plus 2 is 7. Remember, I was trying to make $7. So I've got my dollars, and then 56 cents with the fewest amount of coins. If you said 56 pennies, you missed it because that's not using the fewest amount of coins. What coin could we use? And it would be the fewest. If you said $50, you're on the right track. So I have a $50, a nickel, and a penny. Let's add that together. 50, 55, 56. So I did it. I made my $7 in paper money and my 56 cents in coins. Moving on, we have a larger amount this time, $16.85. Again, fewest amount of bills, but not counting back change. So I have a $10 bill, a $5 bill, and a $1 bill. This amount of bills should add up to the number on the left. This number to the left of the decimal point tells you how many dollars you need. I do not want 16 ones, but look what I've used. I have 10 plus 5 being 15, plus one more is 16. So I did it. I used $16 in the fewest amount of bills possible. Check. Now look at the number to the right of the decimal point, the 85. Again, you don't want to use 85 pennies. Too many pennies. Nobody carries around 85 pennies anymore. Your pocketbook, your change purse, your wallet, or your pocket, it would just not be able to hold 85 pennies very comfortably. So we want to do it in the fewest amount of coins possible. So remember, we start with the $50. That would be 50 plus a quarter is 25. 50 plus 25 is 75. And one more dime makes 85. Let's pretend you couldn't do that in your head. Then you need to set yourself up an addition problem like this, where you add in a column. And that's perfectly okay. 0 plus 5 plus 0 is 5. 5 plus 2 is 7 plus 1 is 8. And there you go, 85 cents. Now the next problem is a story problem. Listen to the story. Dad, Mom, Marco, and Sophia each bought 3 postcards at the Grand Canyon gift shop. How many postcards did they buy all together? Did you hear the word all together in that problem? All together means you add. You add to find the sum. How many postcards did they have to buy all together? If you heard in that story, there were 4 people, and each person bought 3. Now we could make that an addition sentence. 3 plus 3 plus 3 plus 3. We know 2 3s make 6. So now we have a double, 6 and 6, which is 12. Or we could do this a lot quicker by multiplying. When you multiply, you have the number of groups first. So there were 4 people, 4 groups. Write a 4 first. And there were 3 postcards each. Remember, if you add 3 4 times, you get 12. Let's practice. 3, 6, 9, 12. And speaking of practicing, let's say our 5 multiplication family together. 5 times 0 equals 0. 5 times 1 equals 5. 5 times 2 equals 10. 5 times 3 equals 15. 5 times 4 equals 20. 5 times 5 equals 25. Now let me cover up the product, the answer, and see if you can do it. 5 times 6 equals 30. 5 times 7 equals 35. Say it with me. 5 times 8 equals 40. 5 times 9 equals 45. 5 times 10 equals 50. 5 times 11 equals 55. 5 times 60 or 5 times 12 equals 60. Okay? The next thing I want us to do is a thinking cap. This is where you have to really be challenged and use your mind. Use your brain power. Okay, you may want to have a scrap piece of paper. The girls in Sarah's Sunday school class went camping one Friday night. 3 of the girls could not come. How many girls went on the camping trip? Can you solve this problem? What might be missing? No, you cannot solve this story problem. There is not enough information. What was missing, boys and girls? The number of girls in the class was missing. Remember it said Sarah's Sunday school class and 3 of the girls could not come. And how many girls went camping? The story did not tell us how many girls made it to the trip. And then we could have taken away the 3 girls who could not come, and that would have told us how many girls possible. So when you're doing a story problem, you need to have all your facts. And if the facts are not provided, you say not enough information. Okay? All right. I hope that you're learning your multiplication tables and your division tables right now, especially the 1, 2, 5, and 10 families. You can always go on Extra Math for a lot of more math practice. I love you.